So let us discuss a question on theory of machine. This is basically on vibration. So we need to in fact write down the differential equation of the vertical motion of mass m. So what we do is here we, because it's a rigid link, okay, with a hinge joint at the left, so we give a small theta deflection. Always when we write the differential equation, let's for whether you are writing for a spring mass system or a double spring mass system or whatever, you just what you do is you displace a mass by x, because we need to write in the differential equation in terms of the displacement of this mass m and the derivatives all. So whenever you say a displacement mass m is x, so the differential equation is basically governing the motion of the mass m. So it will involve all this displacement, derivatives of displacement, velocity, and double derivatives which are acceleration. So all these terms will come. Okay, so you displace the mass m by x. So let's consider that portion. It's hinge here and it's a rigid link, so it will undergo a linear thing. So this is x, okay, and this will be, because this is a and the total is b, so I think we can use a this is a straight line, so we can basically use similar triangles, and this will be x b by a. Obviously the displacement at the spring end will be x b by a. So now what are the forces? So let's represent forces. This is ox, this is oy, okay, and here you have basically, so gravity is something which we don't consider, okay, because it gets cancelled. The static part we are not considering, because this will have the static deflection, and that we are not considering. We are just considering the we are removing the static part in the deflection. That is as good as removing gravity. So even like you take a spring mass system, you don't consider static deflection and you don't consider gravity, you end up getting the same differential equation. So we follow the same thing, okay, we don't consider gravity. So the only force here then will be the spring force. The spring tries to resist because it gets compressed, so it will try to push, okay, so that push will be k into x, k into delta, which is nothing but k into x into b by a. So these are the forces, the spring force and the gravitational force. So this was our free body diagram, spring force and the reactions. Now we draw, now there is a mass into acceleration, this is m into double. So now we draw the inertia diagram or the kinetic diagram, which represents all the inertias, okay. So the effect of all these forces on the free body diagram will be the result mh dot, which we get it here. So now what we do is we just balance it, okay. So now ox and oy is something which I don't require to know, okay. So summation of moment about o from the right hand side FPD diagram has to be equal to from the inertia diagram, okay, from the right side kinetic diagram. So summation of moment, so it basically means that sigma m is I naught alpha, or so more or less you get in the same way. So this philosophy is more general. Summation of moments in the free body diagram is equal to the summation of moments in the inertia diagram, where you represent all the inertias, okay. So we take O, so summation of moments about O, kx is acting in the opposite direction, so minus spring force is k delta into b is your moment about O, right? So into b, that is the moment about O. I mean we take clockwise positive, so minus k delta into b. It sign doesn't matter even if you start taking, and whenever you are applying any moment equation, you have to fix a direction, whether you want to take clockwise positive or anti-clockwise positive, and then when you end up writing the equation, okay, the equation will be same whether you have started from clockwise or anti-clockwise being positive or clockwise being positive, okay. It's just the same equation, but why we then take clockwise positive is that so that all the terms in that moment equation have to be written on the basis of things. You can't write a single term if it is clockwise positive and then the other term is clockwise, you are writing negative. So you have to define a reference first. So that's what we have defined we have defined that clockwise movement will be positive, and then whatever comes in anti-clockwise direction will be negative. the moment of inertia mx dot, okay, into the moment of this, so mx dot into this a is something which we need to write down. Now we have forgotten one term here, which is damping. Now so damping force will be again opposing, so that will come in this at the mass, and it will be opposite to the velocity. Velocity will be in this direction because the displacement is in this direction, the velocity also will be in this direction. That is what we assume at the start of the writing the equation. So this ch dot is another force which comes upward. Okay, so now when we take the force balance, the ch dot also produces anti-clockwise, so minus ch dot into a, because the moment arm is a about o. So mx dot is the inertia moment, and that is about a. So this is what is the complete equation. So we take all the left side to the right side. So we have done nothing. What we have done is we have drawn a diagram, free body diagram, represented all the forces. The result of all this should be in the kinetic, the inertia. So we have drawn an inertia diagram where we represented only the inertia forces, and inertia forces will be has to be represented at the mass, and so I have represented mx dot. Now summation of all the forces on the left side should be equal to the inertia term on the right side. Summation of all the moments on about a point on the left side has to be equal to the moments about a point on the right side. Just simple mechanics. Okay, so 0. Now you bring all the terms on the right side, so mx double dot, okay, into a is your moment arm, plus ch dot into a, plus k delta. Delta is h b by a, and ultimately we have to represent in b because b is the motion of mass m. So mx double dot, now a can be taken common throughout, so ch dot plus k x b square by a square, where a if you take common throughout or divide by a, so, and also because everything is in terms of x dot, so divide by m also, so h dot plus c by m h dot plus k by m b square by a square into x. So let's compare which satisfies. So first answer A is the one which satisfies this. So always all this kind of thing, what you do is draw a free body diagram, draw inertia or kinetic diagram, and then just balance the moments because at the reaction, so reactions are not needed in your differential equation. So answer is A. Thank you.